Alright, today's the 22nd of April, 2026. I lost my streak. Big sad. I didn't even look at the problem. Like, I just no time, I guess. Big sad. But here we are. Okay, you are given two string arrays, queries and dictionary. Oh no. String arrays. All words in each array comprise of lowercase English letters and have the same length. Wait, the words have the same length? I guess. Okay. In one edit, you can take a word from queries and change any letter of it, any letter of it to any other letter. Find all the words from queries that, after a maximum of 2 edits, equal some word in the dictionary. Wow. Okay. Return a list of all the words from queries that match with some word from dictionary, and after a maximum of 2 edits. Return a list of all the words from queries that match. Okay, so yeah, like a subset of queries such that there exists some word in dictionary that can be made after 2 edits, 1 or 2, 0 to 1 or 2 edits. Return the word in the same order they appear in queries. Wow. Okay, so word, note, ants, and would, joke, and mote. So would, if you take the query would, for example, it can be turned into would after 0 edits. So that should be in the output set. Note can be changed into, I'm assuming mote or no. Wait, what? Note becomes, oh, joke. J and K. Got you, sorry. So note can become joke. So note after 2 edits, so note should be included. Word can become would, I assume, yeah. After 2 edits, so that should be included. And ants, you can try your best, but there won't be any. Okay. Okay, so my understanding is I basically want to know, I guess, the edit distance between every pair. But that's slow, I assume. Is it 10 to the... Oh, it's only 100. Wait, hang on. There's 100 words in queries and dictionary. And the length of each word is maximum 100. Oh, so maybe I can, yeah. Maybe I can brute force this. I take a query. I look at this word versus this word. And I ask myself, how many letters are different between word and would? And if there's no more than 2, then I know I can edit it. And then note versus joke, how many letters are different? If there's at most 2, then I can include it. Ants, I look through each of them. I ask how many letters are different. If there's more than 2, then I can't include it. Would and would, how many letters are different? I should get 0. So I have 100 queries. Is that 100, right? So it will be like, okay, so there's a brute force will work because I think it'll be 10 to the 6. Like kind of, it'll be like order of 10 to the 6 kind of time complexity, like n cubed kind of thing, or maybe m squared n kind of thing, because I will be they're doing every pair, word versus would, word versus joke, word versus mote, um, and for each pair, so there's you know n squared pairs roughly, where n is, or m squared, where m is like the length of queries and dictionary, obviously the maximum length between the two. There's m squared there, and then for each pair, I'm going to be asking, okay, how many letters are the same, or how many letters are different rather, and in that sense, that's like O of n time, where n is the length of each word. So yeah, that'll give like 100 times 100 times 100, so 1,000,000, which will work for sure. We can do that, to be fair. That's not too hard. So output set equals nothing, and we're going to eventually return the output set. And then for query in queries, for word in dictionary, if, and I'll make a separate function, def has close enough, maybe. Given self, given word 1, given word 2. So n is equal to the length of word 1, and which is equal to the length of word 2, it's guaranteed. For I, whoops, not war, for I in range n, so num differences equals 0. If w1 at I is not the same as w2 at I, then num differences should increase by 1, and then for Boolean reasons we'll return whether or not num differences is less than or equal to 2. And we can take away the magic number there. Max allowed edits equals 2, so we can make that. Okay, so we have that, and then if self dot close enough between query and the dictionary word, maybe I'll call it dict word, just to be able to really differentiate. If that's the case, then output set dot append the query, and that will also, and doing it like this with the query on the outer loop will ensure that the order of the like the good queries appear in the same order of the original queries. And then yeah, I think that works. And we can break out as well actually, because we don't want it to do it again. Yes. Because the risk is like, wait, why did the break, the break should have, so if I don't have the break, there's an issue where if I have like A for my queries, and then I have like B, C for my dictionary, if I don't have the break, the A query will appear twice, because it will see it for B and say, yeah, that's good, and then see it for C and say, yep, that's good. So that's why I need a break as well. It's not just for early exit reasons. Yeah. So, Bing. It's brute force. I can't be wrong, right? Like, correctness-wise. It'll be slow, I figure that much, but it can't be wrong, surely. There you go. All right, so it looks like there's like 2 modes, bit bimodal. I mean, this is like the obvious mode, and then this is kind of the second peak, where I guess this is where the brute force happens, and then this is where the clever stuff happens. So my thinking is something along the lines of, if I want to structure this so that I can really quickly find, if there are any words, I'm thinking tries, but I don't really remember what a try is. So I don't actually know if that's helpful. It's probably not, right? Tries is something to do with words and like similar words or something, but I can't remember. But I feel like tries are more about like the same prefix or something. I can't remember. Maybe I should study up for tries. But oh man. Just trying to, I'll do this for like 20 minutes and then. Okay, let's write this out now. I figured the brute force would work, so I didn't bother writing. Normally I would write, obviously. Normally I'd draw. Oops. Come on. Okay. So this is POTD. Problem 2452, sorry. So, yeah, let's say we have, so the queries, for example, look like word, note, ants, and wood. So these are my queries. And then I have my dictionary, the words that sort of truly exist. So, because to be fair, this is basically like auto spelling or whatever, right? Error correction for your spelling. The idea is you have a set of words that exist, and then you have a bunch of words that are user types. And the idea is if queries does not exist, if the word in queries doesn't exist in the word in dictionary, if a particular query doesn't exist in dictionary, you ask, is it possible to edit? Is it possible to edit that query to make it look like one of the words in dictionary? I wrote word really badly in here. I should change this. Hang on. I really shouldn't write like cursive or whatever, like when I'm trying to make each word obvious. Like each letter like separate and like easily readable. Okay, there we go. So, I mean, bearing that in mind, maybe a try is helpful. No, but um, what if I like ask, okay, which words have a W at the start? And then I ask which words have an O in the second character, and then which words have an R in the third, and like I do that across. Does that help? Like, if I know that both word and would for the queries start with a W, and then the word that starts with a W is would in dictionary, and then like for the second letter, like word and note and would start with and I have an O in the middle, and then like all three would, jokes or joke and mote have a O at the second character. I don't know what I'm doing, but I don't know why. I don't think this is actually gonna help me at all. But just something along the lines of like recognizing similarities or like single similarities. Somehow trying to build a graph that lets me go from a word to something similar. Um, word, note, ant, and wood. So, ant. Unless it's just DP again, and like, because this month right has been a lot of DP. What would DP even look like though? What do you? Maybe like the scale, the length of the word. Yeah, but that doesn't make any sense. For n equals 1. For n equals 1, they all appear. Because you just edit the letters to look like any other letter. And that's probably true for n equals 2 as well. For n equals 2... For n equals 2, all the queries could appear because you could edit all of them to look like JO, for example, and make them all look like that. Now, for n equals 3, well, word can become were, not can become joke, would can become mode. Ah, wait, maybe this kind of works because as soon as because ant won't work, right? I can't change two letters because none of the words have an A at the start, an N in the middle, or a T at the end. There's no way ant can be fixed. And since ant can't be fixed at this point, that means that there's no way ants is going to work because with ant alone, you can't. There's already more than two letters you have to change. So ants isn't going to help. Like having an S at the end isn't going to do anything. So maybe like you can kind of exclude it already in that sense. Like you can get rid of it before we even think about. But I feel like I'm just adding. Oops. I feel like I'm just adding more complexity to the problem. Like, how is this any better than just brute forcing? You know, unless I can be really efficient about how I solve this. And then finally, you have 4. So like, okay, um, if I think about ants, right, and I have would, joke, and moat as like the 3 things. Initially, I asked, okay, if we don't think about the whole word and only take the first character, or the first 2 characters even, we know that AN can be converted into WO and can be converted into JO and can be converted to MO, no problem, right? Because I'm allowed two edits. From there, the way we need AN to be able to, the only reason this works is because both letters need to be converted, right? So, how do I say this? We're allowed to do this edit because AN can be converted into WO or JO or MO, but for all three words, you need to use two edits. So, when we think about adding a T for ANT, the only way we can keep these links is if there's a T in the third character. Otherwise, we need to do three edits. And since none of these words have a T in the third character or index 2, all these links sort of disappear. You know? But surely that doesn't improve the time complexity. Like, I'm just kind of doing the same thing in a different order. Like, I'm just checking the characters one by one, and as we add a new character, I just check if it works with the. Unless these sets help. Which words have a W at the start, have an O in the second character, an O in the third character, D in the fourth character? Which words have. Okay, and instead of putting the actual word, we can put their indices for space reasons, I think. And then we do like sets or something. I don't think this feels legit. I don't know what I'm doing. Word, note, ants, wood. So word can link to all of them, or WO can link to all of them as soon as we have an R. Nah, I'm overcomplicating. There's no way. All right, let me cheat a bit. Let me look at what the topics are. Oh, it is tries. Shit. Okay. Yeah, I don't know. I think I remember from like the data structure and algos course is like I'm pretty sure this use case of like you try and do error correction like word auto correction or whatever. What's it called? Autocorrect. Trying to do autocorrect usually uses a try. Like you can use a try, but I don't remember what a try is. Oh man. Okay, wait. So I know tries is like a tree, but the idea is like a tree is an array or something, and like the array is of size 26, and you put numbers in here. Like each spot represents a letter A, B, C through to Z, and you put numbers in here, and that kind of tells you what the thing is, what the current word is like. Unless each node represents a letter. No, that can't be right. Like, yeah, I'm pretty sure each spot has a link coming out of it. Whoops. I could be wrong. I'm like purely basing this on memory. I don't actually I haven't used the try in ages. Um, and then like this maybe links to like over here, and this links to like over here, or something. So like W, which is like over here somewhere, would link to the O, which is like over here, which would link to the R, which is like over here, and then D, which is like way over here, and then note, which is like in the middle somewhere, would link to O as well, which I guess would go here. Or do I need another one? Do I need a whole other node? Oh, I don't remember. Try brute forcing, yeah. For each word in the query, try it, yeah. Oh, okay, so the hints do brute force. Okay, fantastic. All right, we'll cheat. Okay, I don't think I don't remember what a try is. I don't think there's any point. All right, let's just look at this first. See if I can remember how this works. The only edits possible are changing letters. Thus, length of string must be the same and only two charts can vary. Yes. Naive do O of n squared with some early exits. We can also sort the dictionary to be faster since strings are sorted by length. Fair? Yeah, I guess that's fair enough. Since strings are sorted by length, also dictionary.sort. Oh wait, well sorry. I read that wrong. Since the strings are sorted by length. Okay, I'm not gonna. I don't think the sorting thing is helpful. Wait, is this just doing it? For querying queries, found is false. For target in dictionary, if it's okay, so that's not necessary because of the constraints, but fair enough. If the dictionary, if it's less than, then continue. Wait, what? The target minus the query. So if the target is longer than the query, you break out. If the target is less than the query, why would that happen? This would never happen, right? Okay, whatever. For I in range length target. Hold up, what? Is sorting the dictionary that much of an improvement? Am I dumb? Like, this does the exact same thing as me, right? It's just, hold up. I'm cheating a bit. I didn't think sorting would make that much of a difference. Like, I was just thinking of dictionary as an unordered. Okay. I don't really see the difference in what I did, what this guy did. Surely the length thing is redundant. The idea is the length of each query and the length of each target is the same. So like this will never happen. Anyway. Alright, did anyone use a try? Sounds like you. Just but dictance. Okay. Alright. Am I dumb? Like I swear I'm doing the same thing. Am I not? Conceptually? For querying queries, for wording dictionary, if matches query to word, res.append, like, yeah, you iterate. So for each query in target, you have a double for loop, and then you have another for loop within there because you need to check each character. You increment every time that they're not equal, and then you check. Oh, okay, maybe that's what it is. I'm dumb. Hang on. So after you increment, if num differences is greater than that, then return false. There's an early exit in here as well. I only did an early exit in here. That's actually quite silly of me. Yeah, lol. Okay. I should have known that, actually. That's quite sad for me. I fully just assumed you had to use a try in order to be smart, to be fast. But I guess, yeah, enough, if the, yeah, okay. I guess it will happen often enough where you find a word where you already need 3 edits in the first half of the word or something, so there's no need to keep iterating. Yeah, okay. I'm curious about people. I saw in the solutions though, there was someone who used the try. Oh, there you go. Guess a try isn't even helpful apparently. How do tries look like that? Actually, I'm just curious. So you have your link. A node has 26 links in it. Is end is zero? Yeah, you do. Okay, that sounds familiar. The idea of like you need to be able to mark if a node is terminating or not. You have, I guess this is just for space. Tried node pool. Okay, I'm assuming that's like the root. Pointer, the node counter. Okay. You have a class which is has a method which lets you create a new node. Uh, whoa, is this C++? Yeah, I assume so. Structs has to be, yeah. Okay. I don't know what that is, but sure. Node reference equals Oh, yeah, yeah, it is. Sorry. It's the lack of space. It got me. I thought this was one operator. I was like, I don't know what's happening. Node equals the address of, yeah, okay, sorry. Do this. Node is end is false. Okay. So you create a try given a root and a thingy. For char c in word, int I equals c minus a. If node is null, yeah, I got no hope of figuring this out. I don't think. I don't remember what a try does. All right. Well, that was a waste of time.